What is up, guys? It's been a while since I made a video on this. Got a lot going on, so I haven't gotten to work on this too much, but I finally did get the balls to hook up two power sources to one VFD for a test. So right now it's just the AC power right here going to an outlet on the side of the house. So I turn that off. See, the voltage is going to drop. You should go to alarm there in a second. But I'm going to go ahead and turn back on. So right now it's just got AC power. The disconnect is out over there, sitting on top of there for the solar. So basically the AC power is coming in through a cord and it's plugged in, going through these two fast flow fuses, because I just wanted just to pop if there's any sort of weird ground loop or some sort of loop going between the solar panels and the power on the house. Shouldn't be, because this technically is an isolated power source. So it's DC. Going directly in up here. I got it going through a diode just in case. It's just one little crappy diode, but it works. It's going through there for testing. Just in case it's going to backfeed, I want to protect my solar panels. It's going to the DC bus. I'm reading the DC bus right here. 325 volts rectified from the 230 volts input right here. 239 volts AC is the bottom reading there, and the top is the amperage, which I'm reading right here. And I'm just trying to see how it reduces when I parallel in the solar panels into the DC bus. Now this is not a perfect test because my panel array is 300 volts DC. The voltage in the bus now from the AC, that's 239 volts AC rectified, full wave rectification, comes out to 325. Okay, so my rectified DC is higher than the DC bus from the solar. So the solar right now, it's not going to favor the current, it's not going to favor pulling current from the 300 volt input from the solar, but you're still going to see that when I plug it in parallel, it is going to reduce the amps. So I have more solar panels. I don't know if they're enough, but I have two more 250 watters to make my two series 11 instead of 10. It's going to jump my voltage up from 300 to 330 volts, one for each bank, parallel together. So it's going to add 500 watts of power, and it's going to move my voltage from 300 to 330. But right now it's still at 300 volts, which is less than the rectified AC is at 325 DC. So we're going to turn this on. Right now it's just on the AC. This is a single phase motor wired to this. It hates it. Oop, and it even does that sometimes. It pulls a crap load of amps. No ductwork. It's just a blower sitting in there. It's like a fractional horse motor pulling 5.4 amps on my AC power. So needless to say, it's lugging this thing a little bit, just to put a little draw. So it's actually drawed my DC bus down to 308. Might be getting a little voltage drop across these wires, but pulling 5.3 amps right now, right? So if I add the solar in, which is just going to be connected to the same VFD, my amps are going to drop down 3.9 to 4. So basically I'm dropping an amp and a half. I'm dropping from 5.5 almost down to 4 just by adding that when that was at a lower voltage. It's still pulling some of the current, so you guys could do the math, but it's saving probably a good 20%, right there, maybe more. 20%, 25% of what it is there. When I get my DC voltage up higher, it will favor the other way. It'll probably tap most of it off of there. At least that's the goal. I'm gonna have to keep playing with it. This is without doing any transfer switches or anything. So now I'm just gonna turn off my AC input. Boom, 0 amps on the AC. It sagged my voltage down to 298. The sun, oh yeah, the sun is not in the best favorable position. It's actually going down already a little bit. So it dropped my array down to 300 volts, which is at its full rating. And you see no power. So right now this VFD could literally pull off of the solar or off of my home power without any electronics in between. I mean, or any transfer switches or anything like that. So I turn this back on. The array is going to go back up, pulling 3.3 amps. Actually, it's kind of weird. It's like not pulling as much as it was earlier. So I'll go over here and unplug my DC bus, or unplug the solar, and now it's pulling all of it off of the AC power from the house again, over 5 amps. Over 5 amps. There's the DC bus. One more time. Drop the amps down to like 3.5 now. Kind of interesting. Turn off the AC power. Again, it's running all the way off the solar now. Now if I go over to the solar, it's gonna, and pull this, it'll stop. See? So right there, I've basically already proved that I can run dual power inputs into one of these VFDs. I just have to fiddle with getting the voltage higher from my solar array, so it'll favor current coming from the solar without any transfer switches or anything like that. So I might be able to do something later to where I make it switch, but I don't think I need to. I want it just to run. I don't want the compressor to ever stop or do anything weird when we put this 3-phase VFD on this 3-phase condenser I'm going to install. So it's going to be pretty awesome. Now, again, that blower motor is like, it's not pulling as much as the compressor is, but it's definitely a power hog. Because I have like other motors. This is a 1-horse ECM motor hooked up to the same DC input. I'm running DC. I think I already showed you guys that in the past. I think it's still hooked up. Yeah, I have it, both cables going over there. So it doesn't sag my voltage really at all. In fact, let me turn it on, the DC. I know I've showed you guys this before. I think I have. I've made video clips and I haven't even bothered to put them up. So over here we'll read the DC. I'm not going to turn this one on, but it is ready to go if I wanted to. Turn it back off. Okay. The only thing I need is to put a low voltage signal into the ECM motor to tell it to run. So I'm just going to bring this over for that. That's DC right there. That's just what I use to hack it in. Flip that on. It's going to put like 5 volts or 9 volts or something into a couple pins, telling it to run. And now it's going to run. Hold on, recording. So this doesn't sag down the voltage at all to move like the same amount of air. See, it's 312. Like I said, the sun is going down. So that motor over there is very inefficient. Just to show you that it definitely rips down on the power there. So all right, so one of these days I got to figure out where I want to put those 2 other panels. I could put them up there, but I want to save that for a whole another array to go to a mini split later. So might stick them on the side here. Need to get them in the same, so they're getting the sunlight at the same time, because it works together. My wife doesn't really like the idea of me putting it there. It might make it ugly out here, but I don't know. I might do it. So anyway, that'll catch you guys later. Don't forget to like and subscribe and all that stuff. Mad scientist, you guys have been calling me. Got some more stuff coming. Just been slacking. That's all.